Welcome to AI Frontiers. Today's episode examines a single day's pulse of innovation in computer vision. December 21st, 2025. We synthesize 124 research papers from the arXiv preprint server, mapping the frontiers of machine perception, from unified AI minds to 3D world builders. Consider a motion-blurred photograph. To an advanced AI, that blur is not a mistake. It is a secret code containing compressed temporal information. Research demonstrates that AI can now decode this into probable event sequences, reconstructing the past, present, and likely future from a single image. This turns a photographic flaw into a temporal Rosetta Stone, showing machines are learning to see stories, not just snapshots. Why analyze 124 papers from a single day? December 21st, 2025, provides a concentrated cross-sectional view of AI's evolution. The field has shifted from building specialized tools for narrow tasks toward creating unified perceptual intelligences. This narrative synthesizes breakthroughs where machines are taught to see, reason, describe, and create in concert. The grand project of modern computer vision can be understood as a shift from soloists to symphony. The past featured brilliant soloists for narrow tasks like object detection or image generation. The present focuses on conductors harmonizing multimodal capabilities, where pixels intertwine with language and 3D geometry. Every paper discussed today is a note in this evolving composition. A dominant theme is the drive toward unified and multimodal architectures, building cohesive AI minds that see, think, and talk. For instance, visual-aware chain of thought helps models maintain visual consistency when reasoning across multiple reference images, like ensuring a character's green jacket stays green on every page. Another work, CASA, or cross-attention via self-attention, seeks more efficient fusion for long context tasks, making vision and language experts anticipate each other's points for smoother collaboration. The second major theme is advanced 3D and dynamic scene understanding, moving from understanding pictures to understanding spaces and events. Research like HiGeoc aims for precise 3D padoptic occupancy prediction for self-driving, building dense, labeled 3D maps of everything in a scene, not just bounding boxes. Meanwhile, World Warp tackles video generation by maintaining a persistent 3D scene cache using Gaussian splatting, akin to building a digital diorama for geometrically consistent video frames. This is the difference between shadow puppets and full tactile models. Theme 3 is the pragmatic counterpoint: efficient and robust model design, making AI symphonies leaner, faster, and more reliable. D2PRUNER addresses bottlenecks by smartly identifying and removing redundant visual tokens, like a film editor cutting unnecessary frames. On a different architectural front, Efficient Vision Mamba for MRI, super resolution leverages state space models, which scale more efficiently with long data sequences. This enables high-quality medical imaging results with fewer parameters, making deployment on accessible clinical hardware feasible. Key findings from the day's research reveal narrative twists in AI's evolving sight. The paper generating the past, present, and future from a motion-blurred image turns blur into a temporal Rosetta Stone. Bridging Semantics and Geometry, a decoupled LVLM-SAM framework, presents a powerful paradigm, separating a reasoning commander model from a precise segmentation drafting tool. Conversely, From Indoor to Open World, revealing the spatial reasoning gap, exposes a critical limitation, showing models often rely on linguistic priors rather than true geometric understanding in unbounded environments. The paper of the day is Vehicle-Centric Perception via Multimodal Structured Pre-Training by Wenta Wu and colleagues. It addresses a core problem. General-purpose vision models lack deep, ingrained structural knowledge about vehicles. The solution is Vehicle MyB2, a masked autoencoder pre-trained with explicit structural priors. This includes a symmetry-guided mask module that avoids learning redundant mirror image parts, a contour-guided representation module to capture holistic vehicle shape, and a semantics-guided representation module to align image features with text labels and prevent category confusion. The methodology for Vehicle Me V2 involves baking vehicle knowledge into the model's bones from the start. It is fueled by a UTOBOT-4M, a curated dataset of 4 million vehicle images, each paired with a detailed text description for contrastive learning. The 3 guided modules inject domain knowledge directly during the pre-training phase of the masked autoencoder. This approach is not about fine-tuning a generalist at the last minute, but about building a specialist from scratch, analogous to a medical residency for vehicular perception. The significance of the vehicle May V2 approach extends beyond autonomous vehicles. It demonstrated superior performance across 5 diverse downstream tasks, including 2D and 3D detection and segmentation, outperforming generalist foundation models on vehicle-specific work. This proves the power of injecting domain-specific structural priors during foundational learning. It provides a template for other specialized experts, such as Building ME for architecture, or OrganMay for medical imaging, pointing toward a future AI infrastructure as a collaborative society of deeply knowledgeable domain masters. Looking ahead, future directions for computer vision point toward more physics-aware and geometrically grounded models that respect fundamental laws like gravity and perspective. The field will see more modular, decoupled systems for improved interpretability and trust. The relentless push for efficiency will be driven by sustainability and the need for accessible deployment. Finally, deep integration into specialized scientific and clinical workflows is paramount. The ultimate goal is to build tools that act as prisms, refracting the complex light of reality into spectra that human experts, doctors, scientists, farmers, can use to see their own worlds more clearly. In conclusion, the state of computer vision is one of breathtaking maturity and relentless ambition. The field has evolved from crafting isolated tools to conducting multimodal symphonies, teaching machines to perceive stories and reconstruct worlds, while celebrating breakthroughs like generating history from a blur or creating vehicle specialists. Sobering gaps between visual realism and true understanding are confronted. Challenges remain in robustness, the trade-off between unification and specialization, and computational demands. Listeners are encouraged to dive into the papers, join the conversation, and consider how the way machines learn to see will fundamentally shape our shared world. This presentation was created through AI synthesis and review. An AI analysis of the 124 computer vision papers was conducted using a model for content synthesis and narrative structuring. Text-to-speech synthesis was used for the audio presentation. Image generation concepts were described for visual design. A human expert review was conducted for accuracy and coherence. References are provided, though some oversights may still exist. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this content uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by the arXiv preprint server.